Kira, can you hit the light back there? Thank you. Yeah. Now I'm going to start by showing you something on the computer. Then we'll go into the notes. What I need to show you is there's 3 vocabulary words. Do those real quickly. Then we'll go to the notes. If you want to follow along on your computer, you can. You don't need to. This is going to be really short this week. All right, go to our vocabulary. Section 3 has just 3 vocabulary words. And in a second, we're going to write down one of these. The other 2 we aren't going to write down. Well, actually, I guess 2 of them we'll write down. Okay, first definition is distance. And this is going to be between 2 points on the coordinate plane. You don't have to write this down just yet. Just watch for right now. The distance between 2 points, we're going to have 2 different formulas we can use. We just did one of them on GeoGebra. We're going to show you the other one here in a second. And then you get to pick which one you like. The distance between 2 points, oh, what did I do? Hang on for a second. Distance between 2 points is, pause. It's going to be the length of the segment with those points as its endpoints. So they're going to give you 2 points on the coordinate plane. You're going to find the distance between those 2 points. Distance does not have to be a whole number. In fact, a lot of times it won't be, but it does need to be positive. And distance between the points can be found on the number line or on the coordinate plane. We're going to focus on the coordinate plane this year. Okay, now I'm going to show you that formula here in a little bit. You've already learned one of them. We're going to show you the other. So that's how you're going to find the distance between 2 points. You're going to use formulas. Now, the next definition is a midpoint. The midpoint is going to be in the middle of a segment. And it's going to be written as an ordered pair. So if you come down here to this picture, we've got a picture of a segment. And you got these little tally marks to show that they're congruent to each other. That means M is going to be right in the middle of the segment. That makes M your midpoint. So when you hear the word midpoint, you're going to think of right in the middle, point in the middle. Point right in the middle of your segment. And then that takes us to our last definition, which we'll write down here in a second. Segment bisector. It's going to be a segment, a line, or a plane that intersects the segment at its midpoint. So we have this midpoint over here with M. When you draw a segment or a line, it could be a ray, there could be all kinds of different things. When you draw something through the center, through that midpoint, that is called a segment bisector. All right, any questions with that before we go to the notes? Okay. Now for the notes. What we're going to do is always put the date on here because that'll make it a lot easier to find. So any day we do notes, go ahead and write down the date. Today is Thursday, September 2nd. We're doing section 1-3 today. Now, the first thing I'm going to do is kind of recap what we just did on your vocabulary. Let's draw a segment with 2 endpoints. I'm going to call those endpoints A and B. Now, for your notes, all you got to do is just copy down what I'm doing up here. Something for you. Now, if we put a point right in the middle, and to show that it's right in the middle, try to get it as close to the middle as you can. We put these little tally marks, these little congruence marks to show that they're congruent. Call that point X. In this picture, X is the midpoint of segment AB. Put that point right in the middle of the segment, call that the midpoint. And we just had another definition. Let's say I make a line or a segment or a ray, something along those lines, go through that midpoint. Let's call this lowercase m. We have a name for that line or that segment that goes through the midpoint of a segment. Do you remember what we call that when it goes right through the middle? Think of science class. When you cut a frog, when you bisect or dissect a frog, what do you call that? Or where do you cut the frog when you dissect a frog? Right down the middle. Okay. Same thing in geometry, except we call it bisecting instead of dissecting. This line M is the segment bisector. So if you've got a highlighter and you want to highlight a couple words there, midpoint is one of them, segment bisector is the other definition. Now, the only other thing we need to do is show you the two formulas and then kind of some examples of how it works. So our first formula is going to be the distance formula. And this is going to be on the coordinate plane. It's going to be just like what you did on GeoGebra a minute ago. They're going to give you 2 points on the coordinate plane. And then if you want to do the formula where you plot those points on the coordinate plane, you can find the distance of the two sides and do the Pythagorean theorem. You can do that. The other formula, which you might have seen last year in algebra, use a lowercase d to represent distance. And I don't know if you saw this last year or not, but the distance formula, the second distance formula you can use, and the one that ends up being the one most people prefer using. I shouldn't say that. A lot of people prefer using this. Distance formula is going to be the square root, and inside the square root, you're going to have parentheses. You're going to take x2 minus x1 and square it. Add that y2 minus y1 squared. Does that look familiar to anybody from last year? Nobody recognizes that. So you guys must not have gotten this far. So what I'm going to do is just keep this formula, kind of put a little box around this formula. So we're going to come back to that as we do this. And then here's what your directions will tell you. It'll say something along the lines of find the distance between call our first one letter A. For this first example, we're going to find the distance between the points 3, 4, and 7, 2. All right, sense. 7, 2. So now, if you were using that Pythagorean theorem method, you'd put these two things on the coordinate plane. You would graph them on the coordinate plane, you would count the length of the two sides, put it in the Pythagorean theorem to solve for your hypotenuse. That's one way to do it. That might be a little bit more work than this one. If you do this one, what you're going to do is you're going to take your 2 points, and I'm going to call this first point, I'm going to call this x1 and y1. The x coordinate of that first point, the 3, we're going to call x1. The y coordinate of that point, the 4, we're going to call y1. And the second point, I'm going to call the x coordinate and y coordinates x2 and y2. Then we're going to put it into our distance formula. So start by drawing the square root symbol. You have to draw it kind of big at first. So we've got a pretty bunch of numbers in there. And now I'm just going to go to my formula. X2 is 7. So I'm going to start with parentheses and a 7. We're going to subtract from that X1, which is 3. Square. And we're going to add to that, same thing with the y coordinates. Parentheses. Y2 minus y1, your y2 is the 2. Subtract from that y1, which is the 4. Remember squared. Now, before I go any further, are there any questions where I got this part right here? Okay, now once you get to here, you're really doing the exact same thing you did on that Pythagorean theorem method. First thing you'll do is figure out the length of one side. 7 minus 3 is 4. So we get 4 squared here. Add that in our parentheses. 2 minus 4 is negative 2. Square that. It's just a matter of simplifying. What is 4 squared? 16. 4 times 4 is 16. Careful here. What's negative 2 squared? Negative times negative. It's a positive. So negative 2 squared is positive 4. You add those two together. 16 plus 4 is 20. And now here's where you've got a little bit of a choice. When you get to your answer keys on the homework, they're going to give you both simplest radical form and a decimal. Next year in Algebra 2, you're going to need simplest radical form. So let's put this in simplest radical form, because that's what you're going to have to do next year. Square root of 20. What's a perfect square that's a factor of 20? 4 times what? 4 times 5. Square root of 4 we know is 2. Square root of 5 is going to stay behind it. There's your answer in simplest radical form. Put it into your calculator, you would get a decimal. It would be about 4 point something. But since we're going to be doing simplest radical form next year a lot, try to get yourself in the habit of doing simplest radical form. All right, now you've only seen one example. How many think they prefer the Pythagorean theorem method you did on geometry? How many think you prefer this method here? Okay, kind of a mixed bag. You get to choose. Here on out. I'll leave it up to you which one you do. All right, let's go to letter B. For our second example, let's find the distance between the points 2, 4 and 5, 7. So I've got my formula up here. I'll just keep that right up there. Let's go ahead and do this one. We need a big set of square root, a big square root symbol to start with. First set of parentheses, we're going to subtract the x coordinates. If you need to, do x1, y1 here, x2, y2 here. You'll get to the point where you don't need to do that anymore. Now your formula, we're going to go x2 minus x1 in the first set of parentheses. X2 is 5, x1 is 2. It's 5 minus 2 in the first set of parentheses. And then don't forget to square it. We need the plus in between them. Another set of parentheses for our y coordinates. Again, you're going to go y2 minus y1. Y2 is 7, y1 is 4, so that's 7 minus 4 here. And again, you got to square what's in your parentheses. Okay, let's take a quick breather here. Any questions on how I got to this point? All right, now we're going to simplify it. What is 5 minus 2? 3. You got 3 squared here. What's 7 minus 4? 3. You got 3 squared there. What is 3 squared? 9 plus 9. 9 plus 9 is the square root of 18. We want to do simplest radical form. 9 will work there. Yep. 9 times 2 gives you 18. We know the square root of 9, that's 3. Square root of 2 stays behind it. Simplest radical form, your answer would be 3 times the square root of 2. Now, I believe on your test, we're going to make you go to simplest radical form. So even though tonight's answer key will give you both simplest radical form and decimals, try to do that simplest radical form. Okay. All right, any questions so far? Okay, since this is brand new, I'm going to give you one more. I've got to throw some negative numbers in here also. This time we're going to find the distance between -4, 9 and -5, 3. And again, if you need to, go ahead and mark one of your points, x1, y1, and x2, y2. The other point, x2, y2. If you don't need to do that, you don't have to. Then underneath, we're going to do our distance formula. So we've got our big square root symbol. First set of parentheses, do we subtract the x's or the y's? What goes in the first set of parentheses, x's or y's? Y's? No, we're going to do x's first. We're going to do x2 minus x1. x2 is -5. We're going to subtract from that x1, which is -4. You got to square it. In between your parentheses, you're going to have a plus sign. Second set of parentheses, we're going to subtract the y coordinates. y2 minus y1. y2 is 3. y1 is 9. So 3 minus 9 there. We're going to square that also. Am I going too fast? Raise your hand if I'm going too fast. Am I going too slow? Raise your hand if I'm going too slow. All right, perfect pace. Okay, here we got a double negative. So we got to be careful with this. Just like in English class, if you have a double negative, it becomes what? Positive. So I'm going to make those both pluses. What is -5 plus 4? -1. So -1 squared there. Put your plus in between them. 3 minus 9 is -6. And what is -1 squared? +1. Negative times negative is positive. 1 times 1 is 1. How about a -6 squared? 36. Yeah. -6 times -6. Negative times negative is positive. 6 times 6 is 36. That adds up to the square root of 37. Is there a perfect square that's a factor of 37? Nope, there's not. So this one is all the further we're going to go. All right, does anybody need to see another example with a distance formula? Okay, now I'm going to give you the midpoint formula. And the midpoint formula is probably a little easier to do. Remember, your midpoint is going to be right in the middle. If you want to find something that's right in the middle, you're splitting it in half. In math, if you split something in half, that's dividing by 2. So what we're going to do with the midpoint formula, your answer is going to be a ordered pair. So you're going to have parentheses. Put a little comma in the middle because you're going to have an x coordinate on the left and a y coordinate on the right. And then we're going to do just about the same exact thing we did up here, except now we're going to add. We're going to add x1 and x2 together. And then to get them right in the middle, we're going to split it in half, divide it by 2. To get your y coordinate, do the exact same thing. Add the y coordinates together. Now, these are a little bit easier to do. So let's keep the formula where we can see it. And then directions will tell you to find the midpoint between the following. Letter D here. Let's do letter D. All right, for this one, let's have our points be -6, 3, 1, 0. Now, again, if you need to, label one of your points x1, y1, the other point x2, y2. You don't need to do that. Don't worry about it. You don't have to. Now we're going to put it into our formula. To find the point that falls right between those two, we're going to put parentheses first. Our answer is an ordered pair. Let's do the x coordinates first. You're going to add your x coordinates together, divide them by 2. Your x1 is -6, your x2 is 1. You add those two together, then divide by 2, you get your x coordinate. Now for the second one, we'll do the exact same thing with y coordinates. 3 and 0 are the y coordinates. We'll add those together, divide by 2. And then again, it's just a matter of simplifying. Keep your parentheses because your answer is an ordered pair. -6 plus 5 is -5. 2. 3 plus 0 is 3. 2. And then your answer, you can either leave it as a fraction or you can put it in as a decimal. It doesn't matter to me. You can either leave it as -5 halves, or if you want to do a decimal, that's -2.5. 3/2 is 1.5. Or you can leave it as 3/2. Either way is fine. That point is going to be right in the middle of those 2 points there. Oops, sorry. Cover it up and I get it far up. So -5 halves is -2.5. 3 halves is 1.5. That point falls right in between those 2 points. This one's a little bit easier to do than the distance one. Does anybody remember seeing that last year in algebra? Did I get to that either? Okay. Let's try one more, just to make sure we got it. Let's make up the points. 3 what? 3 -2. What's our other point? -9, 4. Okay. Now again, if you need to, label them x1, y1, x2, y2. If you don't need to do that, you can go right to the next step. Get your parentheses for coordinate plane. First spot here is going to be for the x coordinates. We're going to add our x's together, divide by 2. 3 and -9 are your x coordinates. Goes up, divide by 2. Then we're going to do the same thing with the y coordinates. -2 and 4, add those together. Divide by 2. And you simplify. 3 plus -9 is -6. -2 plus 4 is 2. -6 divided by 2 is -3, and 2 divided by 2 is 4. This time you get whole numbers for your answer. Sometimes you'll get fractions, sometimes you'll get whole numbers. All right, that's your midpoint form. How many think that's easier than the distance? Okay, got a bunch there. Does anybody need to see another one of those? Okay, the last thing we're going to throw at you is when they have you do this with algebra. So let's say we've got a segment. Let's call endpoint P and R. And then like we did before, we're going to put the midpoint in here. It's going to be right in the middle. I'm going to call it point Q this time. To show it's the midpoint, we're going to put those little congruence marks to show it's right in the middle. And then what they'll do is they'll teach you some different parts. So in this one, they're going to tell us that PQ is 2x plus 2. So instead of just numbers, we're going to put some variables in there. And the other thing they're going to tell us is that this entire length PR, this length is going to be 10x minus 2. They're going to tell us to find x. And just so you know, this is a new problem we're doing here in your notes. Why don't you call this letter down? So you know it's a new example. All right, now, this is gonna look very similar to what you did yesterday. When you had a point in between, you could add the two little ones together to get the big one. The only thing we need to do is figure out what this missing part is right here, QR. But these little congruence marks are gonna clue me in. If PQ is 2x plus 2, and QR is congruent to it, what would QR have to be? 2x plus 2, 2x plus 2. Now, if you go back to what you did yesterday, when you add the two little segments together, you get the entire thing. So let's add the two little ones together first. 2x plus 2 plus 2x plus 2. Those two little ones added together will equal the entire segment, which is 10x minus 2. Now, before I go any further, any questions on how I got this equation here? Okay, now we're going to combine our like terms on the left. 2x plus 2x is 4x. 2 plus 2 is 4. We've got 10x minus 2 on the right. From here, you go a lot of different ways. You can either subtract 4x or 4. I'm going to subtract 4x. Just so we're all doing it the same way. If that disappears, we should go 4 on the left. 10x minus 4x is 6x. Minus 2 here. Then we can add the 2 to both sides. 4 plus 2 is 6. 6x here. Negative 2 plus 2 disappears. 6 equals 6x. To solve that, you'll divide both sides by 6, which gives you x equals 1. Did we answer the question they asked? Did we find what they wanted? Yep, they wanted x. You find x. That's all you got. Okay, I think that's all. Does anybody need to see another one like this? Okay. Now your assignment today is in the book, which is a little different. You can either use that regular textbook, or if you want your online textbook, you can use that. Website for the online textbook is on the back board back there if you want to use that. Here are the problems we're going to do. And these answers are also on Google Classroom. So let me show you where you can find those. Once you get this written down, is there any more time to write it down? Okay, if I go to Google Classroom, back here. We're on section 3 now, so if you go to section 1.3, distance to midpoint. Your answers for page 31. Right there. You know what? It's got 25 to 30. There's 33 to 40. I don't think we have the right answer to get there. Hang on one second. I may have given you the wrong second. Where is our calendar? Today, page 30. Ah, I did give you the wrong assignment. Okay. Oh. Here, let me switch back. The assignment you're going to do is page 31, 25 to 30, and 39 to 42. Hey, your assignment just got a lot shorter. Okay. All right. You got the rest of the time to work on. You don't have a whole lot of time here, about 10 minutes. If you would happen to get this done today, bring it back. We'll put it in the grade book today. But if you don't, bring it with you next time. We'll put it in the grade book next time you're here.